Hello, and welcome to CU Science Update. I'm your host, Rachel DeBroven. Over the past several months, two devastating earthquakes have impacted our world. The countries of Haiti and Chile have both experienced violent but very different earthquakes. Earthquakes are caused by sudden movement of rock along ruptures in the Earth's surface. You wouldn't know it when you see it, but the Earth's surface is slowly moving. This motion is described as plate tectonics, where huge rigid plates cover the entire surface of the Earth. Since they are moving, these plates rub against each other, sometimes grinding and even getting stuck. Eventually, the strain becomes so great that the rocks break. An earthquake is the shaking that radiates from these breaking rocks. Places that are farther away from the boundaries between plates are less prone to earthquakes, but many major metropolitan areas are located on or near fault lines where potentially devastating earthquakes are known to happen.
The Candlestick Park, for the first time in 27 years, a World Series game will be played in Candlestick Park. The Battle of the Bay continues. Game 3 of the 1989 World Series, the Oakland Athletics against the San Francisco Giants.
Flash forward to the bottom of the fourth inning. Dave Parker, barely by inches, just misses a home run. Candy Maldonado with the hesitation, allowing Jose Canseco to score, and he fails.
Corner of Jefferson and Divisadero, you can see this building is collapsed.
Here comes the footage of the Bay Bridge. We showed it earlier. There is the cantilever section, and there, right at the end of the cantilever, is where the roadway dropped onto the lower deck.
In any given year, our planet experiences some 10,000 earthquakes. Many are small, but some can be quite powerful, like the one that hit Chile. Earthquakes are measured on the Richter scale, invented by Charles F. Richter in 1934. The magnitudes are based on a logarithmic scale, which means as you go up on the Richter scale, the quake's intensity goes up 10 times. Earthquakes that are less than 3.5 on the Richter scale are generally not felt. Under 6.0, slight damage may result to buildings, but major damage to anything that is poorly constructed. Above 6.1, the damage becomes more severe. A major earthquake is considered to be anything above a 7, while a great earthquake is on a scale of 8 or more. Damage depends on the distance of the quake, the quality of the ground, and also the construction standards of the buildings. The earthquake that struck Haiti measured a 7.0 on the Richter scale, but the earthquake in Chile was an 8.8, which is 500 times more powerful than the one that struck Haiti. According to estimates, more than 220,000 Haitians were killed, but the body count in Chile will probably not exceed 1,000. That's probably due to the fact that Chile is wealthier, has strict building codes, and was simply better prepared because of its long history of earthquakes. On the other hand, Haiti is one of the poorest countries in the world. Many buildings were not up to code. Also, the ground beneath Haiti's capital, Port-au-Prince, was less stable, shaking like jelly according to one geologist. Here at CU, scientists are doing their own tests on how buildings can withstand earthquakes. The Fast Hybrid Testing Laboratory has been conducting real-time earthquake simulations to various structures. CU Science Update reporter Kaitlin White has more.
Over the past few months, our world has been shaken by a series of powerful earthquakes. Haiti, Chile, China, and recently Mexico and Southern California have felt some significant shakes. Within seconds, earthquakes can destroy homes, roads, whole communities, turning them into piles of rubble. People caught in the earthquakes can suffer terrible injuries, even death. In Haiti alone, 200,000 people may have been killed in the 7.0 magnitude quake that rocked the island nation in January 2010. Many died when poorly constructed buildings collapsed on them. A few weeks later, the South American nation of Chile was struck by a violent 8.8 magnitude quake. It was 1,000 times stronger than the one in Haiti. It was also the 5th strongest earthquake ever recorded. So powerful was this quake that it even caused a very slight shift in the Earth's axis, which shortened the day by milliseconds. But the death toll in Chile was measured in the hundreds, not the thousands, that would have been expected in such a powerful quake. Why so few deaths in Chile's more massive quake compared to the one in Haiti? For one, the power emitted by the quake in Chile was spread over a very large area. In Haiti, the shaking was more concentrated. But in Chile, better preparedness and stricter enforcement of building codes may have saved more lives. In Haiti, building codes are practically non-existent. These recent events show that lives could be saved when buildings are constructed to withstand the violent shaking of earthquakes. Here at CU Boulder's Engineering Center, the Fast Hybrid Testing Laboratory are making their own earthquakes.
So what we do is, instead of building an entire building and testing it on a shake table to see what happens during an earthquake, we'll test a specific component and then rely on the computer model to tell us what the rest of the building is doing.
Special equipment is used that is capable of shaking apart different types of building materials. 7 actuators apply 1 million pounds of force, which can accurately reproduce the extreme motions associated with an earthquake. The effects are closely scrutinized by the staff and graduate students, looking at how materials crack under the strain.
It's definitely been exciting because it's all new, kind of groundbreaking stuff. Nobody has done the types of tests that we've done over there with the sophistication that we've done it. So it's kind of a first of its kind type test.
The lab is also open for testing by private companies. Many of the results are used to make recommendations for future building construction that can withstand earthquakes. The results could even lead to developing new material that can twist and turn in an earthquake without breaking. Mostly, these tests will ultimately save lives when they are implemented.
The country of Haiti is located in the Caribbean basin as a small part of the island of Hispaniola. Haiti is about the size of Maryland and sits on one of the largest fault lines in the Caribbean. Seismologist and CU Boulder professor of geological sciences, Roger Bilham, sat down with CU Science Update's Damm Muri to discuss the recent earthquake in Haiti.
Well, welcome, Roger, and thank you for visiting us here in the studio.
Nice to be here.
Thank you. I just want to start with asking you, what is your goal with your research?
Oh, well, the holy grail is to predict earthquakes, but I don't think we'll ever do that. So I have a career for life, trying to do it.
You don't think there is no way of predicting earthquakes?
Very difficult. Everyone who's tried has failed. There's a litany of names that goes back thousands of years. Nobody can do it reliably. A number of nutcases think they can do it. A number of scientists have briefly thought they could do it, but we've managed to find that it's almost impossible. And the reason is this: earthquakes start at depth, 10 kilometers below the Earth's surface, and they start as a little crack. And some little cracks stop as little cracks, some grow, and some become gigantic. That's the bit we don't really understand. Why do little cracks underground become gigantic sliding motions that produce damaging earthquakes?
The strike-slip zone, is that...
You're talking about the northern edge of the Caribbean plate. Okay.
Okay.
What actually happened in Haiti earlier this month was that the Caribbean plate had been stuck for about 240 years, and then suddenly it broke loose in a little patch. And the patch was about 60 kilometers long. It was a bit like the Loma Prieta earthquake of 1987, in fact, exactly the same thing, a strike-slip fault. A patch broke and knocked a few houses down. In Haiti, it would have knocked just a few houses down if they'd been built correctly. Unfortunately, they were really badly assembled. And instead of just a few houses falling, just a few houses stood.
Were we aware that this was going to happen at some point, as a start?
The bottom line is that if you're on a plate boundary, it has to keep moving. You can't have it stuck. And there's only two ways it can move. It can either move slowly by a process we call creep, or it can be locked, jammed tight, and then the longer you wait, the larger the earthquake that will release that boundary. But you can't wait forever. You've always got to have an earthquake. So we knew there was going to be an earthquake in Haiti. In fact, the calculations using satellites, measuring the actual movements of the plates, told us that it was about, you could have a magnitude 7 or larger any day. And a few years ago, my colleagues in Purdue University and the University of Texas actually pointed this out to the officials in Haiti. but it's you couldn't do anything in time. You know, the whole city of Port-au-Prince, even if you told them precisely the date that the earthquake would occur, it wouldn't have prevented the buildings falling down. Of course, they would have all fallen down. It would have saved many lives. But although we knew there was going to be an earthquake, we couldn't tell them when it was going to be. And even if we'd been able to tell them within a few years, they wouldn't have been able to do anything. It's just too much reconstruction would have been required.
Right. And so the governmental officials in Haiti, they have always been aware, or they were just recently? I mean, how long have they been aware? I guess I'm trying to compare between the knowledge and the construction.
Well, it's like this. If I went down to, I'll have to give you a parable here. If I went down to the Boulder City Council and told them there's going to be an earthquake in 2 years' time, okay, but I'm not sure whether it's 2 years or 20 years, but it's certainly going to happen in the next 20 years. It could be now. A, they think I was a nutcase, all right, and then B, they might ask, well, how sure are you about this and what should we do? And then they would have meetings and so on. There wouldn't be any urgency. There would be a cool, considered discussion about what the real risk was. What could we do? What could we do to buildings to make them so they wouldn't fall down? Well, in Boulder, they might have taken me seriously because Boulder City Council it's not rich, but it's not an impoverished nation like Haiti. And in Haiti, they were sort of alerted to this 2 years ago and previously in articles. But there's absolutely nothing they could have done except knock the city down and start rebuilding it. The buildings were simply waiting for the earthquake to knock them down. And you don't go around knocking cities down just to repair them. And reconstructing existing houses would have cost the same amount as knocking them down as building them. Haiti was just so, or Port-au-Prince was so badly constructed, it would have cost as much to strengthen the city as to rebuild it.
Right. But does Haiti have a history of earthquakes in the hundreds and hundreds of years back? Yeah.
Hundreds and hundreds of years starts off with Christopher Columbus, of course, in 1492. So there's about a 500-year history. Oh, okay. And in fact, there are dozens and dozens of earthquakes in that history. Port-au-Prince was destroyed in 1750, and then it was knocked down again in 1770. And essentially, we don't quite know where these earthquakes were. We just know they were close enough to do damage, just like the recent one. The recent one, on the other hand, we know everything about it because we got all these wonderful instruments that monitored it happen. In historical earthquakes, you only have an approximate location, and you know where the faults are, so you can just sort of guess where they happened.
Yeah, this was a devastating tragedy, really, in Haiti. And I'm assuming that Haiti or Port-au-Prince is not the only city where there is a chance or more chances of earthquakes. I'm assuming there are many more cities.
Yeah, in Haiti itself, Port-au-Prince, of course, it was an agglomeration. It had spread out over a very large distance, 10, 20, 30 kilometers. But that's not the only city in the world that has this kind of problem. We can list probably 100 cities of different sizes, starting from populations of 500,000 up to 70 million that are overdue for earthquakes. And some of them are ready, and some of them are just waiting to be destroyed. The people who live in them can do very little to reconstruct them because the countries who own those cities are not wealthy enough to undertake the retrofit that's needed.
So now that you're going back to Haiti, in how long?
Well, I probably would be returning to Haiti to install some instruments. Yeah. There are things that geologists do immediately after an earthquake, and then we hand over the baton to other people, earthquake engineers. What's happening in Haiti in the next 10 years, it's going to be reconstructed. It's going to be reconstructed by the world because they can't afford it. In fact, the damage in Haiti is more than their gross domestic product. I mean, it's just extraordinary. It'll cost about $14 billion to rebuild. And because the money's coming from outside, The world has a say in how it's done. In fact, the Haitians would love it to be done correctly. And I mean, here's the good news. Before the earthquake, there were lots of Haitians out of work, 80% unemployment. Now there's going to be a cottage industry in reconstructing not just Port-au-Prince, but probably retrofitting all the other towns there. There will be, in fact, a tremendous influx of education, money to rebuild. And I think, you know, Haiti will come out better than before. It took a tragedy to do it, but I think there's hope.
I'd like to wish Professor Bilham all the best as he continues his research on the Haiti earthquake, and we look forward to seeing you on another edition of CU Science Update. Thanks for joining us.